Okay, so in the last session we have discussed about the panels, SB panel, SSB panel. So today we can see how to design a motor panel. Okay, so in motor panel again, the panel designing everything is same, but there are some minor changes are there when it comes to motor. Motor, it's actually a what? It's a kind of inductive load. Okay, so for inductive load, the starting current will be higher. For example, if you in your house, if you turn on a motor or a pump, you can see that all the light will blink for a second. Okay, for a millisecond it is, but at the starting time it will take more current. Okay, so the starting current will vary from 3 to 8 times the running current. Okay, so in
Okay.
order to regulate the starting current, we are using a element called starters. Okay, so starters actually we have a few types. Here we have DOL starter. DOL means direct DOL, that is direct online starter. So that's the DOL starter. So DOL starters are used if you have a motor pump or a motor pump capacity less than 5 HP. Okay, so less than 5 HP, we'll be going for a direct online starter. Okay, more than 5 HP, we'll go for star delta starter. Okay, star delta starter. More than more than 5 HP. Okay. And in DOL starter, the starting current will vary from there is around 5 to 8 times. Okay, 5 to 8 times. And in star delta, it will be around 3 to 5 times. Okay. So what it is basically doing is in star delta or DOL starter, it will limit the starting current. Okay. In DOL, it will not limit. Okay, so in DOL actually used in small capacity motors so that it will be starting in its full capacity. So the initial torque will be higher for DOL starters or DOL starter motors. In star delta, initial torque will be less because at the starting time it will not start at its full capacity. Maybe in SST 70% it will start the motor for the first starting time only. Then it will gradually what pick up to its full capacity so that we can regulate what the starting current. So that's the idea. Okay. And apart from these two, we have again a soft starter is there. Okay. Then nowadays we are commonly using a starter called VFD starters, variable frequency drive starters. So the advantage is if you are using VFD starters, we can regulate the speed of motor. So that's why nowadays for all the motors we'll be using what? VFD only. Okay, so mainly in the pump side, in HVAC, we'll be using secondary pumps. We'll be using for the chiller side, circulation of water. For that, we'll be using what? VFD driven pumps, so that we can regulate the flow of water or we can regulate the speed of the motor. Thus, we can save some energy. So that's the idea. Okay. So these are the type of starters and the basic idea behind the starters we have. And in here, we have, yeah, this is the symbol for starter. This is the symbol for star delta starter, and this one is symbol for DOL, that is direct online starter. Okay, so here it's an upstream diagram given. As the main incomer, we have an isolator. One more thing, in case of motors, we don't say in what we don't say single phase and three phase in depending upon the kilowatt rating. We'll say based on HP rating. Okay, so if the motor capacity is less than 2 HP, this will be single phase. Okay. More than 2 HP. Okay. More than 2 HP, we will go for three phase. Okay. And most of the time, we'll be saying that capacity in HP, that is horsepower. But for the calculation part, we have to convert to what? HP to
KW.
kilowatt. Okay. So that we have to, the conversion value is 1 HP is equal to
746 watt.
140, 746 watt. That means that will be 0.746 kilowatt. Okay, so if you want to convert means you can multiply with what? 0.746. So you'll convert to SP to kilowatt. Okay, so that's what written here actually. 15 HP, 15 into 0.746, you'll get what? 11 kilowatt. That's it. Okay. And here, yeah, as we mentioned, this is the main isolator. Then we have a bus bar. From this bus bar, 1, 2, 3, 4, 5 motors are taken. Okay. Actually, the connection number is 5. But if you count the motors, we have 1, 2, 3, 4, 5, 6, 7 motors are there. Because in this case, it's actually called working and standby condition. That means the component, like suppose in this case, example is given. For water pump, we don't use a single pump. You'll always have what? Backup or a standby pump will be there. So if one motor is damaged or in a service condition, we have to, again, water supply is important for a building, right? So we don't have to stop that. So still, we have to go for the backup one. That's why it's called working and standby condition. But at a time, one will be working. Okay, so this is the changeover for that working and standby motors. Okay, same way for here also given. Again, water pump 2 is given. Again, working and standby condition. Okay, so when you take the load, it's not the combined HP. This is the HP for the single pump. And in calculation, don't take 5 plus 5, 10. You only have to take what? 5 HP only. Okay. And the first condition is given for STP, that is sewage treatment plant. 15 HP is given. Then water pump, booster pump, jet fan, then water pump. So these are the number of connections we have taken here. Okay. And this is the symbol for star delta, and this one is a symbol for the diode starter. Okay. And the symbols and the resistance symbols will vary depending upon the standards and the company. So this basically we'll be using these. Okay. And coming to the downstream, same way we have first feeder name, then the connected load, maximum demand, current ratings, all these things will be same. But for the motor panel, a bit changes are there. First thing will be, let's take the first one, that is STP. In STP, the total HP rating is 50. So when you convert to kilowatt, it will be 11 kilowatt. So 11 kilowatt will be the total connected load. And it's a motor load. So motor load, diversity factor will be constant. Okay, so in the last case, we were designing SSB and SB, so that if it's a residential load or a normal SD or SSB panels, we can take what? 1.5 as a diversity factor. But in this case, it's actually a motor panel. For motor panels, we have to consider 1 as the diversity factor will be 1. That's the first change. Okay. Then power factor, as usual, will be having 0.8. So that means 11 divided by 1 into 0.8 will be having 13.75 kVA. Okay, so we got the first thing. Then the current rating. Current rating again, it's a 15 HP motor. As per more than 2 HP, it will be 3-phase connection, right? So for 3-phase connection, the multiplication factor. So I hope you remember in the last session we had already discussed
Yeah.
multiplication factor for the 3-phase connection.
1.4.
1.4. So that here also just multiply the kVA value with 1.4, you'll get the ambient rating. Okay. And next, usually we do factor safety for what? MCB. But in motor panel, we don't do that because, again, a quick recap for the MCB class. MCB, we have again 3 classes are there. Okay, B class MCB, C class MCB, and D class MCB. Okay, so why there is classification based on class means there will be always starting current will be there. So if you use a normal B class MCB, will be normally used for the essential loads. C-class MCBs are used for what? Motor loads. Because whenever the pump or a motor is starting, it will take starting current. So if you use a normal B-class MCB in the motor panel, what will happen is the starting current will consider as what? Extra current. Alright. So it will always goes to trip condition whenever you turn on the motor. So that means the C-class MCBs will have the capacity to carry the extra current. It will not identify as what? A false current. So that's why here we don't take factor safety 20%. Whatever is our current rating, based on that only we will select the MCB rating. I guess if you got 90.25 as the current rating, we don't take factor safety. Same, we'll go forward. After 19, next available is 20. So 20 ampere will be the MCB rating. Okay. And here we will do factor safety for cables actually, because MCB will have the capacity to carry extra current, but cables are what? Yeah, cable doesn't have the capacity to carry the extra current. So that's why whatever is your current rating, that current ratings 25 percentage will be considered. So usually if you got 20 ampere MCB means you will go for what? 20 ampere cable size. But here you can see that we have 19.25. So 19.25 into 1.5 will get 24. So after 24, next available rating will be 25 ampere. So we have to select the cable size for the 25 ampere. Okay, so this is the cable size. One runs, three core, and 6 mm square. Okay, and you can notice one thing in the last case for three phase connection, we usually say what? Four core cable. That's for the
Yeah,
panels. For
balance.
three equipments, for the three phase equipments, we have to go for what? Three core cable. Okay, so one runs, three core, and 6 mm square will be the cable size. Okay, and finally, earthing again, same page number you can go for. Okay, so it was 24. So 24 means 25 ampere will be there. Okay, so one runs, three core, and 6 mm square, and earthing same will be 10 itself. Okay, so that, okay, we got the thing. Then finally, voltage. So all are three phase connections, so that it will be 415 itself. So that's how you design a motor panel. So clear? Any doubts? The same way you can design for other panel as well. Same. We have 5 HP, 2 HP, 10 HP. Again, below 2 only will go for single phase. Since it is 10 is 2 HP, you can consider as what? Three phase itself. Okay. Again, the wattage will be low. Okay, but in case of motor, it's actually called constant load. It's not variable. Okay. So constant load means from the starting to ending. Once you turn on till you turn off the motor, it will be consuming what? 1.5 kilowatt itself. Okay, it's not varying in between. Okay. So yeah, that's it. I hope this one is clear. So first major thing to look out is, first thing, diversity part will be different. Okay, so usually we'll go for 1.5 in motor panels, and constant load condition will be 1. Second thing, we don't take factor safety for circuit breakers here. Based on the current rating only, we'll consider the MCB rating. And cable size is not selected based on MCB rating. You will take a 25 percentage extra. Whatever is our current rating into 25 percentage will be taken. Based on that value, we will consider the cable size. Got it?
Correct.
Okay. Then coming to the next one, that is the isolator part. Okay. So here, isolator is in the main incomer side. Okay. And here we can see that we have stabilizer, then we have deolizer. So these are actually mixed. Okay. And what we have mentioned is, for dual starter, the starting current will be 5 to 8 times, and the starter will be around 3 to 5 times. So that means you have to add it separately. Just a minute. Okay, so that so DUL will be having a 5 to 8 times, and starter will be having 3 to 5 times. Okay, so that means if you combine, you have to take it separately. I mean, if you have to add means you have to add it separately for that. Okay, so only for motor panels. Okay, so that here I'll consider the star delta starters low motor separately and the DOL starters root separately. Okay, so 11 plus 7.5 plus 5.6 will be 24.1 kilowatt, and 3.73 plus 1.5 will be having around 5.23 kilowatt. So all this you have to add it separately. Okay, after that, just calculate the maximum demand. For this one separately, that is 24.1 divided by 1 into zero point 0.8. So that you'll get 30.125 kVA. Then for this one, again, you have to calculate the current rating. That will be 1.4 into 30.125. That will be 42.175. Similarly, for the next one also, that is 5.23 divided by 1.1 into zero point 0.8 will be having 6.54, and 1.4 into 6.55 will get 9.15 ampere. Okay. And coming to the last part, that it is factor safety. So usually you'll take what? Yeah, 5%, 5% to 20% we can consider. Here we are calculating factor safety based on the starting current rating, because the cables we already taken 25% extra. Okay. And for MCB, we are using C class MCB, so it have the capacity to carry extra current. But isolators are what? It's actually a switch. The purpose is to just isolate the unit. That's it. It doesn't have any capacity to carry extra current or any protection. Okay. So that we have to take for the star delta one, we have to take 3 times the starting current. Like 3 to 5 is the rating, so you can take consider the minimum. So 3 into 42.17. And for dual starter, it is 5 to 8 times, right? So we have to take what? 5 into 9.5. So once you calculate this one, just add both. Okay, so till this part, we have to take it separately because we have 3 times here and here we have 5 times. Okay, so we'll have 172.28 ampere is the rating. So once you got this one, you can go to the page number 7, then you can find out the available isolator rating. After 170, 160 is the next is 200. Okay, so that the rating will be 200 ampere. Okay, clear?
Just a quick, there is an additional requirement of increasing the motors.
Hmm.
So even in that case, we will go with the same factor of safety. Uh,
No, that one we have to check. Okay,
check,
if there is
check,
any scope of upgrading, you have to check that one also.
check the list.
Because we'll add spare also. Into this panel,
Fair.
we'll add more spares. That's
No
it.
space. Okay.
Okay, so that's motor panel design. And okay, this one we already discussed in last session, SB panel designing. The next is our main panel, that is our MSP plus ST panel. Okay, so here we have quite a lot to find out. First thing we have to find out the LBS rating, that is load break switch rating. Then we have to find out the SFU rating, switch fuse unit rating. Then the transformer rating will be depending upon the total control of the building. Okay, then the MCCP rating and the main incomer. Then the individual MCCP rating, which is going to the each panels. Okay, so we have SB panel 1, 5 common panel. So we have a lot of panels here. So we have to find out these ratings individually and the main side. Then we have to find out a rating for the protection current transformer and the measuring CT. Then the DG, again, depending upon the load or the backup which we had to provide, we had to find out. Again, we'll discuss in the coming sessions how to do that. Okay, so this is the upstream for the MSP panel. Okay, so here the LBS and SFUs are placed in the primary side of the transformer. That means on this side, the supply voltage will be 11 kV. Okay, and the purpose of the transformer is to step down the voltage. So 11 kV will be stepped down to 440 watts. So here the supply voltage will be 440. This is the secondary side of the transformer, secondary distribution side. Okay, so when you find out the rating for these units, you have to use the 11 kV voltage. For this one, you have to use the 441. That's it. Okay. So already the rating is already given, that is 300 kVA is the rating of the transformer. So if transformer rating is 300, here you can see that DG is also given 300. That means it's a full backup condition. Even if there is no supply from the transformer side, the DG alone can what cover the whole panel. Okay. Okay. So coming to the calculation part, again downstream will be same as before. Okay, no changes. And one thing, again, here you can see that there are mixed panels. Okay, so we have SB1 is there, fire pump, common panel is there. So fire pump and the common panel are motor panels, SP, 35 HP and 40 HP. Then we have APFC panel, then we have SP2 panel. Okay, and here SP1 panel and SB2 panel are actually given to SSBs. So that means these two will be variable load. Okay, these three, this one is motor panel, so this will be constant load, this will be constant load, and APFC panel also will be constant load. Okay, so that means you can arrange the table depending upon your idea. So here I have arranged like this: SB1, SB2, APFC, then the final two motor panels. Okay, so here we'll start with the SB1. The total control is 61 kilowatt, 61.5 kilowatt. Since it is variable load, the electricity factor will be 1.5 itself. So you'll get 51.52. Then the current rating 51.52 into 1.5, you get 71.75. Then again 20% factor. It's not a motor load, so we can take 20% of factor safety for the circuit breakers. Okay, so 86.1. And here we have selected a MCCB. So MCCBs, we have two values, switch value and set value. Based on the current rating, we will choose the set value. Like actually, it is given 71, so you don't have to take 70. You can go for what? 75. That will be better. Okay, 75 ampere. And after 86, next available rating will be 100 ampere. Okay, so the selected MCCB rating will be 100 by 75. And based on the switch rating is the 100 ampere. We have to choose the cable. And you can see that it's a three-phase connection, and three-phase connection, if your current rating goes above 50 ampere, you have to go for 3.5 core cable, right? So 1 into 3.5 core into 70. Okay. And then earthing again, if the rate as the rating increases, we have to go for what? Strip earthing here, 25 by 3 copper strip is what used for the earthing. So this is the way to calculate a SB panel in MSP. Okay, so both are same. SB1 and SB2, both are similar. And when it comes to APFC panel, APFC panel means automatic power factor correction panel. So it's a bunch of what capacitor banks. Okay, so that's APFC panel. We'll come to that in the section. We'll discuss about the APFC panel calculation and everything. So in that one, I'll explain. So one thing to notice is APFC panel will be constant load. Okay, so that the diversity factor will be 1 here. It's 25 divided by 1 into 0.8, that will be 31.25. Then we'll find out again, it's all three-phase connection, right? So into 1.4, then into 1.2, then based on 43.8, we'll round off, we'll give us 45 ampere. Okay. After 52, next available is 63 ampere, so that the switch rating will be 63. And based on 63 ampere, we'll go for what? Yes, the cable size. Okay, so again above 50, so 3.5 core itself. Then finally the earthing. So that's it. And finally the two motor panels. Again, motor panel as usual we have done. Here 26.11 kilowatt for the fire pump panel. Again, diversity factor is 1 itself, so 32.64. And current rating into 1.5 will get 45.69. And here it's a fire pump panel, and you can see that the load is 26. So that means it is more than 5 kilowatt. That means you will be having a star delta starter. For star delta starter, the starting current is what? 3 to 5 times, right? So here, instead of taking 20%, the factor set will be considered what? By 3. 45.69 into 3, that will be 137. So based on 137, we will select the set value. So 137 will round off and round off to 140. After 140, the next available rating will be selected as the switch rating. So after 140, next is 160 ampere. So 160 will be the switch value, 140 will be the set value. And based on actually here, okay, again for cables, again 25% you have to consider, so that it will be 57.11, and based on 57 you have to take 1 rod 3.5 core and 50 mm square, then the earthing. This is not the connection going to motor, this is the connection going to panel. So that's why we are not using 3 core cable, this is a 3.5 core cable. Okay, then the same way, next is the common panel. So common panel is also motor panel. Okay, so here also same big and one. 37.3, then we have the current rating 52, then into 3 times 156, 156 round off to a 160. After 160, next available rating will be the switch value, and based on 25%, we will take the cable size, then the earth. Okay, so that's how you design the MSP panel. So this is the rating for these individual MCCBs. Okay, not this one. And this one you have to calculate based on the kVA rating of our transformer. So kVA rating is actually depending upon the total control of these panels. Okay, so that means you can take what directly from here itself. Okay, so that the MCCB for DG and transformer means both are same rating. This one is also 300, this one is also 300. That means both will be having the same rating for these two MCCB. Okay. So 300, it's already given in kVA, so that we don't have to convert that. So 300 into multiplication factor will get what? 420 ampere. Okay. So 420 ampere will be considered as the set. Again, you can take 425 or 430. Okay. Then after 420, next available rating will be the switch value. Okay. So based on 500 kVA, you have to choose the cable size here. Okay. So 500 kVA, sorry, 500 ampere. This 500 ampere is given here. Okay, so runs is 3, and the cross section area is 240 mm square, and core obviously it's more than 50, so that means 3.5 core.
3.5.
Okay, then SFU, again same SFU are also taken based on the kVA rating itself, so 300 kVA. And here you can already mention SFUs are placed in the primary side, right? So here the supply voltage is 11 kV. So when you substitute that, the multiplication factor is considered for the 11 kV supply. Okay, so 0.0525 into 300 got 15.75. Then factor safety 25% again. So 1.25 into 15.75, 19.69. After 19, next available rating is 20 ampere. Okay, so 20 with SFU rating, and LBS again, our calculation is there. So LBS are what available from 12 kV, so you can take 12 kV by 630 ampere. That's the ratings available. Okay, so yeah, that's how you find out the ratings of the HT panel side. Again, one thing is not mentioned here, that is the how to find out the protection rating of the CTs, measuring CT and protection CT. This one is based on the MCCP rating here. So here the MCCP rating is 500 by 420. Okay, so 500 by 420. Okay, so here there is protection CT is there, then measuring CT is there. And you can see that protection series are placed in the earthing side of the transformer. So why means if there is any short circuit, what will happen is the extra current will pass through the earthing cable, right? So whenever there is a conduction through this earthing cable, this is the relay coil. This relay coil will sense that and it will trip the circuit here. So that's the protection series working. Measuring CT is only used for measuring. You can see that into that a meter will be connected. If you want to measure current means an ammeter will be connected. If you want to measure voltage means a voltmeter will be uh, connected. Okay. And here the 420 is the set value. In earthing side, we will take 1/5 of the set current. Okay. So 1/5 means 420, 420 divided by 5 will be 84. So 84 is the value or 1/5 of the current. And you can go to the table page number 14, you can see CT ratios. Okay. So after 84, next available is 150. So 150 by 5 will be the rating of protection CT. Here, protection CT will be 150 by 5. Measuring CT is connected to the phase side here. So that means after 420, next available rating will be the measuring CT. Okay, so after 420, next available is 500. So 500 by 5 will be the measuring CT ratio. Same for the DGR as well because both are same rating. Okay. So yeah, these are the calculation part for the MSP plus ST panel here. Okay. Okay. So yeah. Okay. So this one we all discussed in last class. SB and SCB, SSB and SB we discussed, and this is the common panel for that. This is the motor panel. So you can see that this is the booster pump. DT. I hope this one is dewatering pump or something. And okay, abbreviations are not given here. Okay. Is a schematic, it's not given. Okay, no problem. Then F pump will be fire pump in this case. Okay, so FP here is fire pump. All our single pumps are taken here. Again, here you can see that spare is taken here. Okay, so in case if you're adding more pumps means you can add what spare, and this will be also calculated. The load will be also calculated here. Okay, and here this is CWP means chilled water pump. This is for the chiller side. Chilled water pump 1, 2, 3, 4, 5. Then again, this will be condenser water pumps. Chilled water pump will be there, then condenser water pumps will be. So again, 1, 2, 3, 4, 5. I think this one is okay. So actually only single pumps are taken. There is no working or standby condition is taken here. So all are working pumps. Okay. Then again, in future, if you are taking more, two spare conditions also considered here. Okay. And similarly, all the calculations will be same as we discussed earlier. The kilowatt, then the current rating, then the factor safety, then the MCCB rating, MCB rating, cable size, everything will be same. Okay. And coming to the main part, yeah, this one is our HT panel here. Okay, so again, don't worry about this one. Let's explain. First one, this is the 11 kV side. This is the main income side. 11 kV supply from the EB or electricity board side. Okay, and this connection is first coming to a circuit breaker. That's the VCB. This is the vacuum circuit breaker because VCB is 11 kV supply. So VCB is used in what? ST side. Okay, so you will be having a VCB. Rating is 11 kV. 350 MVA is the rating of that. And these are actually the relay symbols and numbers are given here. I will search for that. I don't have that. Here. Here, all the abbreviations, everything is given here. Okay, so again, check it here. What is abbreviations meaning? Okay, so 14N, right? 14NW. 14NW means that's a triple alarm. Okay, for the trip and alarm, again, see a speaker will be connected. See, for the alarm. Then 50, 51, 50, and 50 is actually again relay. This representing our current relay. Okay, so everything is actually mentioned here. You can check it out. And this one, 51, 51, and it will be the earth fault relay. So that's what mentioned here. Okay. Then after that, one bus bar is taken. It's a bus bar. From this bus bar, two transformers are taken here. So transformer 1 and transformer 2. Okay. And again, same way, two relay cables with the alarm is given here. Then see, this is the cable size. So here, it's a 3 core, 185 is the cross section area here. Okay, 15 meters the distance from the bus bar to the transformer. Okay, and earthing is given here. Earthing is 31 by 6 is the strip earthing. Copper earthing is given. Transformer 1 rating is 630 kVA. It's placed in low and impedance is 5%. Again, I'll discuss this one in the circuit break short circuit calculation. Okay. So the 11 K will be stepped down to 440 and that cable size is given here. So 4 runs, 3.5 core against if the ampere rating increases again 50, it'll go for 3.5 core. So 3.5 core into 400 mm square will be the cable and again 50 meters the cable length is given. Then again, these are the pilot lights, voltmeter is given here. Then this one is our measuring CT. Measuring CT is connected to a okay, it's actually AMB means ammeter. It will be given to a ammeter. And again, this is the protection CT. So here you can see that our MCCB rating is 1000 by 840. It's actually not MCCB, it's ACB. The ACB rating is 1000 by 840. 840 is the set value. Set at 840 means this is the set value, this is the switch value. So 8 port 840 by 5 is 168. After 168, next available rating is 200 by 5. So 200 by 5 will be our 200 by 5 is our uh, measuring CT, sorry, protection CT ratio. And measuring CT, as usual, is this is 840. After 840, next available is 1000. So 1000 by 5 will be your 1000 by 5 is your measuring CT ratio. Okay. Then again, calculation part will be same for MCCB and ACB, both are same. Will be written in the same format itself. Okay. Then the from here, a bus bar is considered. From the bus bar, Chiller 1, chiller 2, APFC, one more spare connection is taken, then AC pumps, APFC once again, chiller 3, SB utility panel, fire pump panel, again one more spare. So, these are the number of connections taken from this one. Okay, and again, we have two transformers. Transformer 1 is there and transformer 2 is there. Okay, and we have DG is also given, DG1 and DG2. So that you can see that this one is 630 ampere, this one is 625, again this one is 630, this one is 620. That means these are full backup condition. And one more thing, you can see that there will be a one more ACB placed in between. Okay. So the purpose of this one is if there is no power from the transformer side, that means DG will be taking care of these panels. Okay. So this panel, whenever the DG is turned on, this will be turned off. So that this DG will cover 1, 2, 3, 4 panels, and this DG will cover 1, 2, 3, 4, 5 panels here. So we are actually splitting the bus bar to two parts. But manually we can go and turn it off. Okay, in case if you require or again it's not necessary, but in some cases this is the load manager system. That's why we have a ACB in between. If there is no ACB means we will be a single system. In order to isolate the bus bar, we are using a ACB here. So that this transformer 1 and DG1 will be covering this part, and transformer 2 and DG2 will be covering the right hand side. That's it. Okay, and the individual MCB rating is given here, and the again machine CTS as well. And for the chiller, same motor load, right? So that a starter is on here. Then again, chiller 3, SB utility. These are actually SB panels, fire pump panel. Then yeah, that's it. So these are the number of panels taken, and the calculation everything will be same as before, and the table contents and everything will be same. Okay. So this is the breakup of our MSV plus ST panel. I hope this one is okay. So in the coming classes, we'll be discussing more about this one. I'll be designing this one also. So any doubt in this one?
No, sir, no doubt.
Okay. Okay, so I hope session is okay. You can wind up for now. Next day, okay?
Okay, sure. Thank you, sir.